Hi everyone, welcome back to my channel. Today we discuss about some problems related to the proving identities. We'll see that how we can quickly prove some identities here. Before that, let me review some trigonometric formulas. Okay, here uh, sine theta times cosec theta, that is equal to 1. Okay, that we already discussed about this. Okay, and here cos theta times sec theta equal to 1. And tan theta times cot theta is equal to also 1. Okay, from here, the first one, we can get sine theta is equal to 1 by cosec theta, and cosec theta is equal to 1 by sine theta. Okay, and from here, we can get cos theta is equal to 1 by sec theta, and sec theta is equal to 1 by cos theta. And from here, tan theta is equal to 1 by cot theta, and cot theta is equal to 1 by tan theta. Okay, let's continue the formulas. Here, tan theta is equal to sine theta times cos theta, and cos theta is equal to cos theta times sine theta. Okay, and here sine square theta plus cos square theta is equal to 1, and sine cos square theta is equal to 1 minus sine square theta, and sine square theta is equal to 1 minus cos square theta. Okay, so these are the three important formulas here. Let's continue the next one. Here cosec square theta minus cot square theta is equal to 1, and cosec square theta is equal to 1 plus cot square theta, and cot square theta equals to cosec square theta minus 1. And here again, sec square theta minus tan square theta is equal to 1. Sec square theta is equal to 1 plus tan square theta. And tan square theta is equal to sec square theta minus 1. So what you need to do is that you have to remember all these formula. So just make a note of these, all the formulas, and try to memorize all these formulas. Okay, so that we can use these formulas in proving identities. Okay, let's quickly discuss about the techniques. Okay, how we can prove the identities here. Okay, I'll try to give you the quick techniques here. My first technique is that, okay, convert every ratios in only sine and cos. We have a 6 trigonometric ratios, right? So what you need to do is that except sine and cos, you need to change every ratio in terms of sine and cos. Let's get example. Here, prove that cosec A times sec A times tan A is equal to sec square A. Okay, here LHS is cosec A dot sec A dot tan A. So what we need to do is that you need to convert every ratio in terms of sine and cos only. Okay, so what we do here, cosec A is 1 by sine A, sec A is 1 by cos A, and tan A is sine A upon cos A. So we change every ratio in terms of sine and cos. Now if we cancel sine A and sine A, what we get here, 1 upon cos square A, and that is equal to sec square A, right? Which is the right hand side, and it's proved. Okay, so the first technique is convert every ratios in terms of only sine and cos. Okay, now let's come to the next technique, and that is change in direct formula. So direct formula means when I just gave you all the formulas, you need to remember them and try to convert, try to change into the direct formula. Let's get example here. Here sine theta root under 1 plus cot square theta plus cos theta root under 1 plus tan square theta equals to 2. Now here LHS we have taken here, right? Now remember 1 plus cot square theta we can change directly into the formula. So what we can do, that is sine theta excuse me, root under cosec square theta, right? 1 plus cos square theta is cosec square theta here, plus cos theta 1 plus tan square theta, direct formula is sec square theta. Okay, now let's remove the root here. We get sine theta times cosec theta plus cos theta times sec theta, which means that here the product gives you the 1 plus 1. You know that sine theta times cosec theta is 1, cos theta times sec theta is also 1. So 1 plus 1 gives you 2, which is the right hand side, and it's proved. Okay, now the next very important thing in proving identities, the technique is you always need to remember you have to factorize the given expressions. Okay, that's very important. So let's get example here. Here you can see cosec 4 theta minus cosec square theta equals to cot square theta plus cot 4 theta. I said to factorize. So when you say to factorize, remember the first thing which comes in your mind is taking common. So I'm taking the LHS here. In the both expression, I can take the cosec square theta as a common. Then what will remain? It is a cosec square theta minus 1. Now we have already learned many techniques here. So now keep your eyes on the right hand side and remember what we need to do. We need a cot. So I can change cosec square theta directly in terms of cot. So what can I do? It is a 1 plus cot square theta. Cosec square theta is 1 plus cot square theta. And what about cosec square theta minus 1? That is cot square theta, right? So now let's multiply them. We'll be getting cot square theta plus cot to the power 4 theta, which is the right hand side, and that is proved. Okay, now Let's get another example. Again, I'm continuing with the factorize. Okay, when I say the factorize, it's not only the common. There's a lot of things you need to do here. Now let's look at here this example here. I'm taking the LHS. Now let's think for a moment. Okay, what can we do here? We can just simply do here like this. So what I did here, actually I have used as the in the numerator a square minus b square form, which is equal to a plus b times a minus b, right? Now here it is cos square alpha minus sin square alpha is exactly in the form of a square minus b square. So I'm just taking here a plus b times a minus b, which means cos alpha plus sin alpha and cos alpha minus sin alpha. In the denominator, you can simply take the common. So what is the common in the two terms? That is sin alpha times cos alpha. So which gives you the remaining factor as cos alpha minus sin alpha. From here, we can cancel this and this. Okay, now look at here. What remain? It is cos alpha plus sin alpha divided by sin alpha times cos alpha. Can I do like this? Now you must be wondering what I did here. Let's look at here. If this is a term a plus b by c, can I do like this? A by c plus b by c. I just separate the denominator, right? If I take the LCM, I'll get it back again. So I did the same thing here. Cos alpha plus sin alpha upon sin alpha times cos alpha. I just made it here cos alpha upon the denominator, sin alpha times cos alpha plus sin alpha upon sin alpha times cos alpha. Okay, I'm using the same technique here. Okay, now I can cancel this and I can cancel sin alpha times sin alpha. So what do I get? 1 upon sin alpha plus 1 upon cos alpha. And we can use the direct formula. Look at the right hand side. We need here cosec alpha. 1 upon sin alpha is cosec alpha plus 1 upon cos alpha is sec alpha. That is equal to RHS. And that's proved.